Hello everyone, my name is Gemehl. I'm a student in nuclear energy technologies and I will be presenting to you in this short video the climate change issue. Since the start of the Industrial Revolution in the 18th century, we have burned enormous amounts of fossil fuels to power the economy and to deliver unprecedented prosperity to a huge number of peoples. Fossil fuels seemed to be the ideal energy source. First came coal and the steam locomotives. The first machines of the Industrial Revolution were invented, and after a few decades of research, oil and gas also began to be extracted and used. We thought that those resources were harmless and inexhaustible, and so their extraction and consumption kept on increasing. The problem is that we cannot do without them nowadays. But why is fossil fuel consumption a problem, some would say? Well, fossil fuels are organic matter made from the remains of flora and fauna, which were subjected to immense pressure and heat deep within the earth during millions of years. Petroleum, coal, and natural gas are the most important fossil fuels consumed. But together with the energy released when the fuel is burned, an equivalent amount of carbon dioxide is released into the atmosphere, which now turns out heats up the atmosphere. We call carbon dioxide and other similar gases the greenhouse gases. To compare the greenhouse gases emission per fuel type, scientists use a special unit, the equivalent amount of carbon dioxide released per unit of energy produced. We can clearly see a big difference between fossil fuels and other kind of fuels. The emissions are almost divided by 20. Despite this, we rely on fossil fuels for our energy supply for more than 80%. Besides the fact that they will become scarce, they are also polluting. It's therefore with no surprise that we observe a direct relation between our fossil fuel consumption and the greenhouse gas release. But what effects does the greenhouse gases really have on Earth? Well, the greenhouse effect is a natural phenomenon vital to life on Earth because it assures an average temperature of plus 15 degrees Celsius instead of minus 19 degrees Celsius with those greenhouse gases. The Earth gets energy from the sun in the form of sunlight. The Earth's surface absorbs a big part of this and heats up. Earth cools down by giving off a different form of energy called infrared radiation. But before all this radiation can escape to outer space, greenhouse gases in the atmosphere absorb and re-emit part of it to Earth, which heats up the atmosphere. Then, as the atmosphere gets warmer, it makes the Earth's surface warmer too. The atmosphere always contains greenhouse gases, which allow the evolution of life on Earth. But the burning of fossil fuels has led to a concentration of greenhouse gases in the atmosphere which is much higher than a few hundred years ago. As a consequence, Earth heats up more than before, slowly but surely progressing towards irreversible events in the ecosystem. Today, the average global warming is about 0.9 degrees Celsius and between 2 and 4 degrees Celsius in polar regions. If the level of greenhouse gases keeps rising, we are approaching 3 major tipping points after which things can get out of control. The first one is the ocean pollution tipping point. 25% of the carbon dioxide released in the atmosphere is absorbed directly in the water of the ocean, which acidifies. The ocean is already 30% more acid than during the pre-industrial era, endangering the plankton species, which are pillar of the marine ecosystem. The ocean works like a gigantic that filters air and water and produces the majority of the oxygen we breathe. The plankton's death would mean the end of it. The second one is the ice cap melting. Ice caps fulfill the role of a gigantic mirror, reflecting the sun rays back to space. But its melting could trigger a dangerous chain reaction. As the albedo gets smaller, the sun rays are able to hit the Earth, which gets warmer. And the albedo gets smaller again. This is the exact definition of a tipping point. Once you've passed it, there is no way back. The final tipping point is the permafrost thawing. The permafrost is a giant frozen underground in which hundreds and hundreds of tons of methane are trapped. With global warming, a first layer of soil may defrost, causing the release of methane into the atmosphere. Methane, being one of the most dangerous greenhouse gases, it would provoke a sudden warming leading to the second layer defrost, etc. and etc. Another unstoppable chain reaction. But the question is, what could we do about it? When energy demand is anticipated to rise by 40% before 2035, and fossil fuels are so polluting, it is our first priority to reduce greenhouse gases by orienting our energy production towards a low-carbon energy mix. We must develop each and every energy source which can help us to reduce our greenhouse gas emissions. Although renewables and nuclear power have a very low CO2 emission per unit of energy produced, they do not represent today more than 7% of the current worldwide energy mix. From these two options, nuclear energy is man-controlled and can produce huge amounts of energy, while being able to adapt the energy supply to the demand. Both renewables and nuclear energy face substantial economic challenges, but would be more cost competitive than fossil fuels if the greenhouse gas emissions would be properly priced. But because renewable energies are not yet sufficiently mature to fill the entire energy demand, nuclear energy is needed and could help us to reduce our greenhouse gases emissions efficiently within the short period of time that we have available before climate change becomes uncontrollable.